Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Winterlight, and today we're going to be looking at Azure Event Hubs and how you can use this for streaming data on Azure. Hi guys, today we're going to be talking about Azure Event Hub and how this relates to other types of messaging platforms that we've talked about already on Azure. Now we've already looked at Event Grid, which is useful for getting data out of Azure when something happens on Azure. Say I create a blob and I want to respond to that. Well, I can use Event Grid to respond to that event. It's going to emit a message, and then I can wire that up using any number of different services on Azure. We've also looked at Service Bus and how you can use this as a general purpose tool for building out messaging inside of applications. Now, Event Hub is more of a specialized version of Service Bus in that it's designed for sending messages, but it's designed more for streaming data versus just sending messages like Service Bus does. Now with Service Bus, what you have is a publisher and subscriber. The publisher will create a message, put it on the Service Bus, and the message will stay on the Service Bus until either the message expires or the client, that is the subscriber, will connect to the Service Bus either to a topic or to a queue and pull that message and respond to it. With Event Hub, that's not the case. With Event Hub, what ends up happening is you have the producer produce the message, and the message is put onto the Event Hub. Now, what the Event Hub is wanting to do is forward that on to the consumer right away without persisting that on the Event Hub for any period of time. If there is no consumer, then the message is more or less dropped, and it is not persisted in a way that will allow the client to connect at a future date and then download or pull that message and then respond to it. So that's the biggest difference between just Service Bus and the general context and what Event Hub is trying to do. Now, I did say that the message is dropped and it is not persisted on the Event Hub. There is a way in Event Hub to persist messages so that if a client were to disconnect and it needs to connect at a future date and get older telemetry that was coming from producers, then there is a way to persist that to something like a data lake or blob storage. So it's not going to throw away data in this sense that you're going to lose it unless you just want to. But the use case for Event Hub is strictly around that streaming type of workload. So it's going to assume that you have a live publisher and a live consumer, and it's just going to be basically brokering the connection between the producer and the consumer by collating messages and then forwarding those on to a consumer. So let's go look at this in the more abstract sense, and then we'll go over to Azure Portal and show you what this looks like there, and then I'll show you some code samples of how it's implemented. So Event Hub has the same basic architecture a Service Bus has, but it's based on Service Bus. But instead of calling it a publisher, we call it a producer. Now, a producer could be anything. It could be an IoT device. It could be back-end process. Whatever it is, it has some kind of event that needs to let something else know about. And that's what we call a producer creating a message. And then it puts that message onto the Event Hub. Now, there could potentially be thousands upon thousands of these producers all creating messages that get sent to an Event Hub. And so Event Hub is designed to be highly scalable. It can consume potentially millions of messages per second, all being generated by these producers. So it's got ways of partitioning those out and different schemes for handling that scale. But the basic point here is that you have just thousands upon thousands of messages coming into the Event Hub from all these producers that kind of get forced into that Event Hub. And then on the other side of that, you're going to have a consumer. Remember, this is oriented around streaming. But Event Hub can be configured to persist data to something like a blob storage account or a data lake. And as I mentioned, this is oriented around streaming, and it's assuming that there's going to be a client to consume the messages. It doesn't persist them like a Service Bus would. It's going to forward it, or it's not going to do anything with it. So if you don't want to lose data, you can configure Event Hub to write all of that to a storage account or a data lake, and then you can go back at a future date and then read those messages. But if there is a consumer, the consumer will be there to receive those messages as they come off the Event Hub. And it can also go back and look at the blob storage account or the data lake to read anything that has been persisted to that blob storage or data lake as well. So this has the potential to grow massively and also archive lots and lots of data that's coming into the Event Hub. Now, this basic architecture is one that you will find a lot of times in IoT workloads because it's a very popular way of capturing events, but also persisting them in a way that will allow someone to come back and look at those at a future date. And it's using a file format called Avro, which we'll see when we go and look at this in the Azure portal. But this is the basic architecture, and I just want you to kind of have your head around this when we go look at this, because it's important to understand that these are the basic working components of it. It's also important to understand that the streaming orientation of this basically means that you have producer to Event Hub to consumer as a linear flow without interruption. And if there is an interruption, it basically breaks the flow and it doesn't try to persist it on the Event Hub for the persistent life of the message. Rather, it just drops it or it writes it to a permanent storage solution such as blob storage or data lake. So with that in mind, let's go over and look at this in the Azure portal so you can get an idea of what it looks like there, and then we'll go and look at some code samples. So I'm here in the Azure portal and I have a resource group with 2 resources created. I have my Event Hub namespace in my storage account, and my Event Hub namespace is the parent resource for Event Hubs. And this is obviously where I'm going to be storing the messages whenever they come through off of an Event Hub. Now, if I come down here into the Event Hub namespace, I do want to look at something in this, mostly the scale, but most of this stuff is pretty typical of what you would have inside of an Azure resource with shared access policies, networking for firewalling and private endpoints and that kind of thing, and other types of settings that you might have for common resources on Azure. The one I do want to call out is the scale right here. And this is because it uses something called a throughput unit, which in an Event Hub is basically a function of bandwidth, which is the number of bits per second that you want to allow for on your Event Hub, or the number of messages per second. So 40,000 messages per second or 400 megabits per second, depending on what the threshold throughput unit is going to have on it. And this is one of those things that's going to impact your billing whenever you tune this. So you don't want to over allocate this or in that sense where you're going to be paying for more than you need, but at the same time you don't want to under provision it to impact your performance. And that's why they have this auto inflate right here. You can set a maximum threshold on this, and this will allow you to have up to a certain number of throughput units, and it will auto scale the actual throughput units depending on the demand that's coming in through your Event Hub. So this is a nice utility to set this up. If you kind of know what your metrics are going to look like, and that's pretty predictable, then you probably don't need the auto inflate. But if it's going to be variable and you don't know what that's going to look like, maybe turn this on, and that will help you have billing in line with your actual consumption. Other than that, the only other thing I do want to look at under this particular pane is, of course, Event Hubs. And this is where I can create and manage the Event Hubs that I'm going to have in my Event Hub namespace. So my scale is a function of all the Event Hubs that I have inside of my Event Hub namespace. Now, if I wanted to create an Event Hub, I can simply click on Event Hub right here, and I can create a new one. So if I go blaze-eh-2 or something like that, I can create a new one. Now, I do want to look at these 2 sliders right here and then this capture right here, because this is where I configure where messages are persisted. Now, partition count has to do with downstream concurrency. So you can have a lot of junk being pumped into your Event Hub through events that are happening from your producers, but downstream you can only have so many consumers. So the more partition counts you have, the more possible consumers you have. So that's what this particular slider is going to be for right here. Message retention is for retaining messages on the Event Hub. Now, I said earlier that Event Hub is not intended for long-term message retention. It's not like a service bus where it's going to maintain a message either till the message expires or something picks it up. It's not really for that. So don't tune this expecting the message to be there when the next time your client connects. This is really for playback. So in the event that you're doing development work and you want to go back and be able to replay messages through an Event Hub, you can turn on retention up to 7 days and you can go back and replay messages through the Event Hub because the retention is turned on. And so this is good for debugging things or building models on or things like that, where you're going to be doing more dev work or debug work, but this is not something that you should count on for the kind of thing that you would want a service bus for, which is to have a message sit on the actual service bus until something picks it up. This is not for that. So don't think that's what this is doing whenever you turn that particular slider on. Now, if you do want to persist messages in a way that you can access them at a later date, that's what this capture feature is for. And this is where you tune the capture feature right here. And this is basically the time window for however many minutes for the interval before it actually goes and writes data to the blob storage account or the data lake. And this is the threshold, like how many megabytes of data do you want to do before it actually writes the file. So if you want a tighter time box, 1 minute. If you want smaller files, tune that down to 10 megabytes, whatever it might be. And so you can then use this to tune that. And that's just basically going to shape how the file structure, or how many files really you have inside of your blob storage account or your namespace. And this is where you can choose storage account or your data lake, depending on which one you're using. And then this is where you can go out there and you can pick whatever it is you're using. You selected data right here, but I've already done that for my other particular Event Hub, so I'm not going to reconfigure this one. So once you have that configured, you'll have something that looks like this. And this is what the Event Hub looks like. And the Event Hub has the ability to go back and reconfigure the capture if you so choose. And you can see where mine is shaped according to 1 minute and 10 megabyte files. And that's because I'm not pumping a lot of data through this. And in the actual container, it's going to create a structure that looks like this for the actual data path. So namespace, Event Hub, partition ID, year, month, day, hour, minute, second, and then that's going to be the name of the file is the second. And that's how it is going to look. So I'm going to end up with something that looks like that for the file name in my given Event Hub and the storage that's associated with it. Now, this, once it's set up, it's just a matter of attaching your producers and your consumers to it. Now, you can also do something with this, and that is do Event Hub processing through Stream Analytics. I'm not going to get into that today. That's a future video for another time. But this is where you can connect Stream Analytics to an Event Hub and do real-time processing on it using Azure Stream Analytics, which is the streaming service for querying and massaging data in real time on Azure, and then you can attach alerts and other things related to that. However, we're just looking at it mostly from the context of developing producers and consumers, and then seeing how those actually behave once we have our Event Hub set up. So once you have this, the next thing that you'll need to get then is your shared access policy, and this is where you can go over here, you can create one of these, and you can get your connection strings. And I already have my connection strings. And this is what we're going to be using in our code. So let's go look at the code, and we'll use the code as an example to show you kind of how this behaves. So I have up here in front of me the clients that I'm going to be using for my producer and my consumer. Now this is my producer, and it's pretty straightforward. It's the same basic code that I use for Service Bus. I just adapted it for Event Hubs, and I changed very little of the logic. It's just basically changed the SDKs and some of the calls to some of the methods and give it a new connection string, and everything works fine. And it's basically just sending up to 10,000 messages that are spread out by about 100 milliseconds. So the producer is pretty straightforward. The consumer code on this is different than what you might do with something like a Service Bus. And that's because this uses this idea of a blob storage checkpoint. And this is basically a way of bookmarking essentially where you last looked at the messages that were coming through the system. And that's what this library is for. It's a specialized library that uses blob storage to look at, okay, I last checked in an hour or 2 hours ago, and so I'm going to basically bookmark that. And so the next time I connect, I know where I was the last time I looked at the code or looked at what was there. And so I can just get the changes in the messages and so on. So this right here is the basically just listening for messages other than that piece of the code. So again, a pretty simple piece of code here, but it does have that additional nuance with the actual storage that it's going to be using in conjunction with this, because again, event hubs are not really intended for persistence. Now, when I said earlier that they don't persist messages, that's maybe not entirely true. They do persist messages, but it's not something that is tunable or something that you can really say with any confidence that the message is going to be there the next time your client connects. So that's why you cannot depend on it. And that's why you shouldn't depend on it. So this is, again, designed for streaming, and you might get the messages next time your client connects, but the intent is not to assume that it will be there. Rather, it's something that you just expect the client to be there whenever the message is published, that the consumer will be there to receive that message. And if not, that it goes and gets it from a persistent storage, if that is so how you configured the actual Event Hub to behave. So let's go ahead and start this producer and consumer. I'm going to first start the consumer because I really want that to be there once the messages start coming through. So node index.js, and this is just going to sit there and wait for messages to start coming through. And let's go ahead and start this right here. This is our producer, and I'm going to start with this one with node index.js. And this is going to just start sending messages up to my producer, which is right here. To my consumer, which is right here. And those are coming through basically as I send them, it's going to start writing them. Let's start up another instance of my producer here, and I can just start up these to my heart's content, and let's create a few more just to see how this is going to work. And so we can have lots and lots of producers and a single consumer that's basically going to be handling all of those messages that are the producers are going to be writing into the consumer. So my consumer is going to be going nuts right about now. I mean, again, this is not going to be nowhere near the capacity of what an event hub can handle, but you can see here that this is getting messages at a much higher rate than I'm able to produce them with my given producers, which are producing them at a much slower rate. So you can kind of see there, that's what's going on with these various producers and consumers. And if I kill these off, again, you're going to start seeing the drop off of the number of messages that get produced on this particular consumer over here. And I still have one of these that's going right here. And if I kill this one off, then this is going to stop receiving messages right here. And if I start it back up, then we should start seeing messages resume. So again, multiple producers to a single point, basically few consumers, lots of producers that are going to be coming in through the Event Hub. So you kind of get this funnel effect where everything's kind of going into a consumer from a bunch of different producers based on events. And this is, again, for streaming data. So you don't want to assume that the message will be persisted. Now, with that in mind, let's go over and look at the persisted data in any case that is in the storage account, because that is where the messages are going to be written for a long-term storage solution in the event that I need to go back and look at those, and I need to make sure that those are being processed if something about my consumer were to go down. So here's the storage account that I'm going to be looking at, and the data is in a container called data. That's just what I called it. And it's in this particular folder here. And if I drill down into this, you can see that it is the Event Hub namespace. And this is the Event Hub. This is the partition, year, month, day, and then here's the hour. And you can come back up. I've got most recently this hour right here. So if I go back over here and look at some of the messages that I might have saw earlier, this one right here, and this is going to be one of the data files that came through. Now it's going to write one of these regardless if I had data in it or not. So I'm basically just going to get one of these and download it. So once I downloaded this, this will be in my downloads folder, and the resolution on this, again, is depending on how you configure it. Now, I have set up IntelliJ on my machine because IntelliJ has a built-in Avro viewer. If you launch IntelliJ, you can download the IntelliJ idea from the internet. And then once you have it downloaded, you can get a plugin for it. And the plugin is basically just a plugin that you can install in IntelliJ. And it is just the ability to look at these Avro files, which are more out of the Java world than they are out of the anything, because they came out of the Apache space. And this is the plugin you can get for it. And you just download it, drag and drop the zip file on top of IntelliJ, and then it installs this tool down here, this Parquet Avro file viewer. Now, Parquet is used in data lake workloads. It's a tabular format designed for data stores that are tabular in their orientation but aren't databases. So it's a file format that's useful for that kind of thing. And this is one that is best used for Avro files because it's really the only tool. There's other tools out there, but this is probably the best one for it. So once you have the file downloaded, you can basically just drag it over here and look at it. And this is the schema. And if there's data on there, it's just a tabular data that you can look at. And so this is exactly what we were seeing. And this is the historical data, message ID. And you can see this is, you know, the data that was coming through, the sequence number, the system data, etc. And this is basically just, you know, tabular data that was in that given time box for the resolution that I set. So for a given minute, this is what it produced. And this is the schema that it read, and then this is the data. Now with streaming analytics, you can use SQL-like queries against this data to filter it and do transforms on it, that kind of thing. So that's going to be another video for another day, but this is how you can work with the Avro files in the event that you want to kind of see what's going on in those. But otherwise, the data is just persisted in the structure that we saw whenever we looked at the storage account. So hopefully this video has given you some context on when you might use an Event Hub compared to something like Service Bus. Now, I've tried to make the distinctions between these two services because they are very similar in their approach. And Service Bus is more general purpose, and this one is oriented around streaming. So hopefully you've kind of seen that in the way that the service is set up and the various options that you can tune on this for the various kinds of things that you would use it for. Now, we're going to be adding two Event Hubs and Service Bus and kind of linking some of this stuff together so you can kind of get an idea of an end-to-end solution on Azure for a hot path type of data. We've looked at batch-oriented workloads, and we looked at the platform as a service offering through Azure Data Factory. And of course, there is also Databricks that you can use for both hot path and batch-oriented workloads. But this is just looking at more the platform as a service offerings. And we're going to kind of link some of these together so that you can get a better idea of how this would look like in a real-world solution where you have data coming in through something like maybe an Event Hub, and you're piping that into a solution that is going to be able to process that data and then present that through some kind of API or something like that. So look forward to that video, and hopefully this will kind of give you an idea of the messaging suite that is available on Azure.
If you like this content, please consider visiting us online at www.wintelect.com, and there you can find about services that Wintelect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintelect on Twitter at WintelectNow or at Wintelect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintelect.com. Until next time, thank you.